All right, class, today we're going to actually start in chapter 4. And if you notice the title of the chapter, it's called Polynomials. Now, what do you think this prefix poly means? That's right, poly means many, and nomials means number. So we're going to talk about many numbers. Now, we're going to actually cover two sections today. We're going to look at section 4.1, which has to do with exponents. We did a little bit with that last year, and then we're going to look at how to add and subtract polynomials. Now, the first thing I really want you to look at is look at the table of contents. If you go and look at the table of contents in our book, we're going to see that they actually break chapter 4 down into 3 different sections. Okay, we're going to talk about exponents, and then we're going to talk about adding and subtracting. The next section is all about multiplication of polynomials. And then the very last part, the last division of chapter 4, is story problems. So I kind of wanted you to see how we're breaking it down. And so now let's go ahead and start with section 4.1. And that's everybody turn in your book. And let's look on page 141 and 142. There at the beginning. Now, the whole objective of today's lesson is to write and simplify expressions involving equations. And if you look there, they use the powers of 5 as an example. So if you're looking there, it says the first power of 5, 5 raised to the first power. If you look there, my exponent is a superscript equals 5. They've got the second power of 5. What's another way of saying the second power of 5? That's right, 5 squared. So 5 squared equals 5 times 5, which everybody knows is 25. The third power of 5. That's right, another way to say that is 5 cubed. So if you look there in your book on 141, it says 5 cubed equals 5 times 5 times 5. And then when we get past second and third, or squared and cubed, we're at the fourth power of 5. A 5 raised to the fourth power is 5 times 5 times 5 times 5. And we could go 5 to the sixth power, 5 to the seventh power, and so on. So hopefully you've noticed there that we have pretty much a generalized rule on how to say the nth power of b. Now b stands for my base, so that's b. N is the exponent, and so we're just going to say b times b times b until we get to the nth power of b, however many times they say. And so that's our generalized rule as we go through here. Now, let's go ahead and look at my next slide. Now, if you look here, I want you to look at my first example, which is right here. And what is my base? That's right, the base is -3. What is my exponent? Remember, the exponent is the superscript raised above, so that is 4. So what does 4 tell me about the base? That's right, 4 tells me how many times -3 is a factor. So this means we've got -3 times -3 times -3 times -3. Now, we're going to go back to something I used to say a lot in chapter 1. Did you recognize there's a parenthesis? Remember, we've got to know who's in the parenthesis and who's out of the parenthesis. And if we look here, hey, is my answer going to be positive or negative? That's right, it's going to be positive. I have an even number of negatives, so this is going to be positive 81. Now, let's go over and look at my second example. Oh, did you notice something's missing? That's right, there's no parentheses here. So what is my base? Well, my base is 3. What is my exponent? My exponent is 4. So here's what they're asking me. Remember when they put that negative sign out in front of a number? They want the opposite. So they want the opposite of 3 times 3 times 3 times 3. Ooh, now, is my answer going to be positive or negative this time? That's right, it's going to be negative, and this time it is -81. Okay, so please, 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 big deal. Make sure in chapter 4, when we're looking at these bases, who's in the parenthesis and who's out of the parenthesis. Now, how about if we went down to this next problem and I told you to write an exponential form? Well, remember, it's algebra. It's a number thing and a letter thing. So usually the procedure is we put the numbers first. So we've got negative 3 times 2, which is negative 6. And then we deal with the letters. Okay, so if I look there, then what's x times x times x? Well, that is x cubed. Very nicely done. Now, because of what we said, let's see if you remember what happens here. What's the answer to letter A? Ooh, did you notice no parenthesis? So that means this is negative 36. But when I look at letter B, negative 6 is inside the parentheses, so that's my base. Negative 6 squared is negative 6 times negative 6, which is positive 36. Let's look at letter C. Ooh, no parentheses, so we've got to use 5 minus, well, we learned 3 to the 4th is 81. What's 5 minus 81? Yeah, we've got negative 76. Oh, wow, look, when we put parentheses, it changes everything. What's 5 minus 3? Well, 5 minus 3 is 2, and 2 to the 4th power is 16. So again, please pay attention to who's in the parenthesis and who's out of the parenthesis. Now, just a little note to remind you, order of operation is PEMDAS. Now, if you remember back in chapter 1, okay, we saw, parentheses. We do what's in parentheses first. Now, exponents are in play, okay? We've got to remember we're going to do parentheses, then exponents, then we take care of multiplication and division, and the last thing we do is addition and subtraction. So just a reminder, now that we're in chapter 4 and we're dealing with exponents, we have to remember the E in PEMDAS is now in play. Now, if you look up here, this is actually example number 3 in your book, and they want me to find the area of a rectangle. Well, I need you to know the formula for the area of a rectangle. That's right, area equals length times width. So let's look at my rectangle. Which one of those terms is my length? That's right, the length is 11x. Okay, that means the width is 3x. All right, a number thing and a letter thing. What's 11 times 3? Everybody says 33. What's x times x? X squared. Now, the next 2 problems that I've got on here to get us ready are actually examples 5 and 6 in the book. And I throw them in here because I need you to slow down a little bit when we're looking at PEMDAS, order of operations. So remember, now that we're in chapter 5, okay, E for exponents is going to come into play. So let's go ahead and substitute and evaluate the first problem here. Well, there's my parenthesis, and I've got 3 times 2 plus 2, and S is negative 4, and there's the back half of my parenthesis squared. Okay, now if I look up here, PEMDAS says we're going to do parentheses first. So let's look. What's in parentheses? Ooh, we got a bunch of operators in there. Which operation do we do first? Oh, that's right. We do multiplication first. So we've got 3 times 2, which is 6, plus, what's 2 times negative 4? Negative 8, that's right, and we've still got that squared out there. Now, we're going to do what's inside parentheses. What's 6 plus negative 8? We've got negative 2 squared, and then what's negative 2 squared? Well, negative 2 times negative 2 is positive 4. So again, I'm just trying to get you to slow down a little bit, and let's check what's going on now that E is in play in PEMDAS. Let's go ahead and look at the second problem here. We'll make it the blue problem. Let's substitute what we know. Well, we've got parentheses, and then we've got 2, x is 2, minus y, which is 5, and that's cubed over 2 times 2 plus 5. Now remember, we learned back in chapter 1 that a division bar, okay, is like a grouping symbol. So let's take care of the numerator. What's 2 minus 5? Oh yeah, now did you realize that was negative 3? Negative 3 cubed over, and we've got 2 times 2 is 4 plus 5. Now, What's negative 3 cubed? Well, negative 3 cubed is negative 27. 4 plus 5 is 9. So what's my final answer when I reduce my fraction? Negative 3. Good job. Now, that's all there is for section 4.1. So please pay attention to parentheses.